Hi everyone. This quick video is going to be about slide 3 from Tuesday's practice. So if you open up your slide deck, you can see the feedback from me on if you made any errors. This video will also allow you to hear again what makes a graph be categorized as as a function or not as a function. So let's get to it. I'm going to get my pen available. All right. So as we look at this first graph, you can see that it is a circle. And what we have to do to use the vertical line test, that's the name of the test that we use to test a graph. So, oops, let me go back to the other one. I'm probably going to have to use this. So we are going to, let me get my pencil, there we go. So now we're going to grab that vertical line. Actually, I'm just going to make a vertical line. So we're going to draw that vertical line through my graph, and I can see that my vertical line intersects the circle here as well as here. So that's 2 points in which my vertical line intersects my graph. Therefore, no. The law of the vertical line test says if it's more than once that graph does not represent a function. So this would be a no. Here, the only place, and I'm going to change the color of this so that you can kind of see it against the black graph that's already there. So if I have to draw a vertical line through a vertical line, it actually has to go right on top of it. And every single point that green vertical line intersects the black vertical line is every point. So therefore, no, this is not a function. This has infinite amount of intersection points since every point is. So we call that infinite amount of intersection points. So this one is a no as well. So here we have a black V-shaped graph. If I draw a vertical line through it, I can see once. I have to find any place on here to graph a vertical line that would intersect more than once. And hopefully you can see no matter which type of vertical line I draw, yes, this V-shaped graph is actually a function. Here we have a curve. You will study this in high school. However, if I draw a vertical line through this, you can see that it's a function. My vertical line only intersects that black curved graph at one location. So yes, this represents a function. Here we have an oval. If I draw a vertical line through, you can see that 2 points of intersection telling me that oval is not, no, that is not a function. Here we have a straight line that is increasing. If I draw a vertical line through here, all of my vertical lines would just intersect at one location. Therefore, yes, this straight line does represent a function. Here we have a downward shaped U graph. If I draw my vertical line, I can see those intersection points, and those intersection points, again, would only be one intersection point for every vertical line. So yes, this downward shaped U is a function. Here we have a V graph, similar to number 3, but this one's on its side. And when I draw that vertical line, I can see that 2 points of intersection leading me to no. This shaped V graph is not a function. However, this one that's upward facing is a function. Here we have a curve, again, very similar to the one above. The one above, the curve goes left to right, but now this curve goes from top to bottom. And when we draw that vertical line, you can see that curve is not a function. This one actually intersects 3 times. In my last one, we did a U-shaped graph right over here. That U-shaped graph was pointing down, and therefore all the vertical lines passed. But when that U-shaped graph is pointing left or right, when I draw that vertical line through, you can see those 2 points of intersection, leading me to say no. That U-shaped graph that goes left or right in either case would not represent a function. So again, I tried to double up some types of lines. Here we have a straight line that is increasing on an incline and it passes, but this is a straight line that's vertical and it doesn't pass. So I was trying to get you to see different ways that we can represent different types of lines and curves, and which ones do actually pass the vertical lines and which ones don't. If they do pass, which is one intersection point, that is considered a function. And when they don't pass because there's 2 or more than 2, as in this case, that would be no, this graph does not represent a function. So go back and look at your slide in your feedback and see where your error occurred.